My name is Neil Hatley, and this is TE Transducers Part 5 and 6. Neil Hatley and Dale Stevenson, Group A for ELT 495 of Thomas Edison State University. Our device, the TE Transducer, is current automatic testing method stimulates disinfects electrical safety test TE transducers. The TD100 delivers high-level disinfections to TE probes in only 5 minutes. The TD100 disinfects each TE probe with high-level disinfectant and provides printed verification upon completion of a successful disinfection cycle. Microprocessor controlled, the TD100 is simple to use for any healthcare professional resistant to use TE probes. Also, with the TD100, it dramatically reduces the amount of stress and the potential for damage to TE transducer probes. The system was designed with every aspect of the TE probe taken into consideration. The control handset is held securely within the TD100, while strain and stress is minimized from the cable and electronic pack adapter with specific design hanger and mounts for both. So in other words, it takes off the stress on the ultrasound transducer adapter and the dual connectivity probe, so you have a less likely chance of breaking the device when doing the cleaning and sterilization of the TE transducer. The next cleaning solution I'd like to talk about is a ULT 2000. The BC Biomedical ULT 2000 series can also be easily utilized before or after the disinfecting process for a combination disinfecting and electrical leakage current testing process with such systems. So the ULT just allows for easier cleaning and testing of the TE transducing device. Shown in the image to our right here is the BC Biomedical ULT 2000, which is in the testing solution and also hooked up to the transducer adapter, so it can give feedback on if there's any leaks or any kind of problems with the TE transducer. I think in our design we would use the ULT 2000 as it feels like the best all-in-one device in order to use with our transducer. The next subject I'd like to talk about is the LED display. LED stands for light emitting diode. In a lot of devices, if you go out in the field, you'll see the programming device is very small and very hard to work with. With our device, we like to make it somewhere around 7 inches, which will make easier programming, user-friendly interface, and less room for error when it comes to the technician having to update or design a different type of protocol for our TE transducer. I feel that the bigger the screen, the easier it is to read the directions and the easier it is to program. And I feel like that could be a very big thing that the medical field could use when it comes to testing this device. Next would be a valve, which is a magnetic level gauge. This type of gauge will determine where the leaks and the disinfecting solution will need to be added. This device can detect leaks fast and is very cost effective in terms of tools that we can use for our device. Our main thing we'd like to incorporate in our design would be our barcode scanner. Anytime you go to a hospital, you always get a wristband that has a barcode on it, and they scan it with the device just to make sure you are the correct patient. With the TE transducer, I feel that the patient would be under, so it'd be very hard for them to OK or tell their birth date. So I feel like our barcode scanner would be a very important tool when it came to scanning to make sure this is the correct patient. It would also make less user error when it comes to scanning because there's less communication between the patient and the doctor. Also, tracking the device. You could easily track the device and determine how old the device is, what errors or what problems the device has, what pieces have been replaced on the device, just to make sure everything is there. Maintenance with our device is the main reason we would be using the barcode scanner, is it could tell the technician what all has been done, how old a certain part of the device is, and what has been changed and what not has been changed. The world we live in today is all about big screens, clear screens, and I feel like with ours we would need to have a big 7-inch or larger PLC touchscreen display to make it easier for the technician or the nurse or the doctor just to see what's going on and have an easy feeling when they came to using the tool, just to see, if there's any problems with the device. It could display errors and all that information that they need to know right in front of their hand. And another thing we would use is programmable logic controllers. Anytime you use a PLC, the startup cost is going to be more expensive, but overall, the capital cost and the maintenance cost would start. It would pay for itself in the long run. This would help to eliminate errors and also keep the device up to date with ever-changing medical trends. Overall, the TE transducer, we feel like with the barcode scanner, using the PLC, larger screens, it would make it a lot more user-friendly and a lot more safer for the patients and doctors that use the device every day. Also, it would keep to the device in less downtime in order for the hospital to make more money and run it through more patients. Thank you, and that is the end of my slideshow, and I hope you enjoyed the demonstration.